So now that we've covered the next batch of observable operators, let's take a look at a case study that'll put all the pieces together. And we're going to look at this case study in two parts. Part one of the case study is going to show how to use a whole slew of Rx Java observable operators, like the ones listed here, to create large random big integer objects and asynchronously check to see if they're prime in a new background thread. And we'll get a chance to see a lot of the stuff that we've been talking about and how those things work. And you can find this particular example in the link at the bottom of the slide. It's in the ex2 project in the reactive observable folder in my live lessons GitHub repository. So we're now in the IntelliJ project for the case study ex2 Rx Java example. And as usual, we're going to start off by taking a look at the driver program. And this is going to demonstrate using a bunch of observable operations to do some processing with big integers to check for prime. And you're going to see there's two methods here. One is called test is prime timed, and the other is called test is prime async. We're going to look at test is prime timed in this particular example. And as you'll see, we're going to register both of these methods as method references using the async task barriers register method. And then once those things are registered, we're going to start them all running by using the run tasks method on the async task barrier. And that will return a single, and then we can use blocking get to wait until all the asynchronous computations are done before continuing on. And I had started running these things in the background earlier, and here's the output. We'll take a look at the output here in a moment. So let's go ahead and start first by taking a look at test is prime timed. So first of all, let's go ahead and take a look at the class itself. We have the class is called Observable EX, which is usually what we name it. We're going to have a maximum random number, so you can't have random numbers that are bigger than 10 million. We're going to have a maximum number of iterations, which is 10. We're going to have a lower bound of randomly generated numbers, which is from the max integer to the max iterations. And then we're going to go ahead and create a new random number generator, which we'll see how that gets used in a second. We then create ourselves a prime cache, which is a concurrent hash map. So we're going to use a memoizer technique here. And then we go ahead and define a sleep duration, which will be a half second, which we're going to use for the interval time thread. We're going to make ourselves a predicate that returns true if something is odd. So it checks to see whether something is not even, in which case it would be odd. And then we finally have another method that generates a random big integer. And this random big integer goes from the lower bound to the up to the value that's returned here. Okay, so let's go ahead and see how this thing's going to work. So here's test is prime timed. And this uses an asynchronous time-driven observable stream that processes random big integers to determine which ones are prime and which ones aren't. The first thing it does, it makes a string buffer, which we're going to use to store the results so we can print them out in one fell swoop rather than having them sort of pop out of nowhere, because these computations will be done in the background in different threads. We use a string buffer because string buffer is thread safe. We then go ahead and make ourselves a little logging consumer, which is going to be called log big integer, and it will print the results to the string buffer whenever it's invoked. And you'll see how that gets used in a second. Let's now take a look at how this code starts. We're going to use the create method. Remember, create is this factor method that's going to generate a flow of random big integers that in this case are going to be generated at a periodic interval in a background thread. And we do that by passing in a method reference to the emit interval method. And we'll look at that method in a second. So what that method's going to do is it's going to use the observable emitter that's passed to it, and it will essentially sleep for a half second, and then it'll generate numbers starting at 0. We don't actually care what the numbers are. We don't want to generate 0, 1, 2, 3. We just want to have something that's driven at time intervals. So we totally ignore the value, and instead we call the sGenerate random big integer function, which will generate the appropriate random big integer. We then go ahead and keep in mind that the interval method is going to run in the scheduler computation thread pool, or scheduler's computation thread pool. So it's running in the background. This is running in the background thread. You'll see that when we show the code, and it's displayed by the print statements. So we're generating random big integers in the background, and then we're going to filter out ones that are even, only allowing odd numbers to go through. Because what's the point of checking to see if an even number is prime? It's obviously not going to be prime. We then take only S max iterations of these things, and so that's basically 10. We're going to have 10 of these iterations. And then we go ahead and use the subscribe terminal operator to say, when everything goes fine, pass the method, pass the event up to the calling stream that's chained together with create. If something goes wrong, shut things down, and if we're done, we're done. So those are the methods that are called there. So all those computations take place in the background. So now let's come back over here to test is prime. You can see that we are going to generate a stream of random big integers up to 10 in number. And then we're going to log them, and we're going to say what thread they're running in. And then we're going to go ahead and call the map operator. Now this map operator is going to be called in the thread. It's in the background thread, the thread where the interval is being emitted in the computation scheduler. And what it does is it checks to see if the big integer is prime. And all it does here is it makes a new prime result. And the prime result is going to take the prime candidate, which is the number we're checking for primality, and use the good old compute if absent atomic check then act method on concurrent hash map to say, have we already got a value that we know the factor for this prime number or this prime number candidate? If so, return it from the cache. Otherwise, call this function, which will check to see whether or not the number is prime. And this is just doing a very brute force prime check, intentionally brute force time check to see whether or not the number is prime. So that'll return this thing that's called a prime result. And you can see here's the prime result. In this case, we made prime result be a static class. It would have been trivial to make this a record. I should probably change it to be a record because that's a more modern Java way of doing things. So that's what check if prime does. And then what we get out of there is this prime result, which we then process. And you can see here what we do is we check to see if it's prime or not. And we print the results. And then what we do is when we're all done, the doOnCompleteHook method is going to display the results from the string buffer as a string. So we're going to print the results, and we'll look at the results in just a second. And the very, very last thing we do is we return the completable from the ignore elements method. This is that suppressing method we looked at before. And that's an indication to the async task barrier framework that this asynchronous computation is done, and therefore it should decrement its count of things it's waiting for to finish asynchronously. And when they're all done, then the method that's the blocking get method that's called back over here in the ex2.java file will return when everything is finally processed. So that's basically how we do this code. Let's take a look at what the results were. So this is the one that's the test is prime timed. And you can see we're running in a thread in the background pool. This is what the interval timer is doing. This is what the interval method on the observable is doing. It's running in a single thread in the background. And basically, every half second or so, it's emitting a value. And that value is then being checked in the background thread to see whether or not it's prime. As you can see here, we're emitting odd numbers. We're checking to see if they're prime. And we're also, of course, using our memoizer to see if we can return things without having to actually redo the computation. So, for example, you can see that here, in this case, we see certain duplicates being generated, and therefore the memoizer cache will be nice and look that up rather than having to recompute that value once again. So that's the behavior that we see for the one that's the timed version. What's also interesting, and we'll cover this when we talk about the second half of this, even though we ran the isPrimeTimed method first, if you go back and you take a look at the ex2 driver program, you can see that we registered things so that we called test is prime time first before test is prime async. But because of the fact that this is doing timed computations, it actually finishes after test is prime async. And we'll talk about why that is when we talk about the second half of this example.